The regions A, B, and C in the figure above are bounded by the graph of the function f and the x-axis. It says if the area of each region is 2, what is the value of the integral from -3 to 3 of f of x plus 1? So, I'm going to be honest with you, there's a lot going on in this equation, so let me kind of break it down for you guys slowly. First of all, let's figure out what they're asking us to do. It says if the area of each region is 2, what is the value of this integral from -3 to 3 of f of x plus 1? So a couple things we're looking at here. First of all, we want to know from -3 to 3, and I want you to notice that it's actually already broken up into 3 intervals. Now, we don't know what this function is, so we don't know how to calculate the area, but luckily for us, they told us that the area of each region is 2. So A is 2, B is 2, C is 2. Notice that the ones below the x-axis will be negative, and the one above the x-axis will be positive. So this is -2, +2, -2. So that's the first thing we need to keep in mind, is that we're breaking this integral up from -3 to 3, we're breaking it up into 3 pieces. The second thing I want you to notice is that we have f of x plus 1. So remember, this would be like a vertical shift of the graph. So it's like taking f of x and literally shifting it up 1. Alright, so remember that we wrote these problems as 2 separate problems. So we said the integral from -3 to 3 of f of x dx plus the integral from -3 to 3 of 1 dx. And so I drew on the board, hopefully you were there that day and you remember that I drew on the board, what does the function 1 look like? And you guys told me that it looks like a constant. So a constant function 1 would literally look like this. Alright, and so if we look from -3 to +3, and I drew my little lines here, and I said, okay, great, calculate the area under that curve. Alright, I hope it's very obvious to you that that's a rectangle, so the area under the curve should be very easy to calculate. So from -3 to 3, that has a distance of 6, and this has a height of 1. And so the area under that curve would be 6. And again, I do that for the purposes of showing you where I'm getting that number from, but I would hope that from here you would not need to do that. You just calculate the distance between -3 and 3, which is 6, and then multiply that times the 1 that's here. So hopefully you guys don't have to actually draw it out. It saves you a lot of time just to look at it this way. So, now let's break this first one up. So if I break up this first one into the 3 separate parts, I can't actually write, because I don't know what numbers these are, okay? But let's just say that, that these are certain points. So we break the integral up from -3 to this point, then from this point to this point, and then from this point to this point, and if we add them all together, it should equal from -3 to 3, okay? So, from here to here, okay, we have an area under the curve of -2. Then from here to here, +2. From here to here, -2. Okay, so do you see this pattern that's forming? So we have -2, and that middle area is +2, and that final area is -2. And then this piece here that I just found from this rectangle is 6. So when I add together -2 plus 2 minus 2 plus 6, that equals 4, which is answer choice C. So again, lots of moving parts here, not difficult parts, but lots of moving parts. Having to understand that you can break this up into, that rectangular area plus the area under the f of x curve. And then breaking up -3 to 3 into these 3 separate intervals is also very important.